In this problem, we have a marble slide. On it, a marble is released from height h. So it goes round this loop of radius r. We have to find the minimum height from which the marble must be released so as to go around the loop without losing contact. Here are some preliminary considerations. First of all, how to judge whether two bodies are in contact. When two bodies are in contact, there is a action-reaction contact force pair between them. It is called normal reaction. Whenever contact is lost or is on the verge of being lost, the normal reaction would become zero. Number two, when the marble loses contact, it will be in the upper half of the body, and then again it is more likely to happen at point B, because that is where the gravity is acting in the most unfavorable direction, trying to tear away the marble from the slide. But if it doesn't lose a contact, then it will go around the perfect circle, executing circular motion, and behind every circular motion there must be a centripetal force. And at point B, the centripetal force towards the center, or the downward force, would only be gravity, because if it is on the verge of losing contact, there will not be any normal reaction. And finally, the energy of the marble will be assumed the same all through this journey. Now let us take stock of this energy. At point A, the marble is just let go without any kinetic energy, so its entire energy is in the potential form mgh. While at point B, it will have potential as well as kinetic energy. The potential energy will be mg into this height, which is 2 times the r, or diameter of this loop, and the kinetic energy expression is half mv square. If we consider the centripetal force while going around this circle, it is mv square upon r. At point B, it is served by the gravity, so we can equate weight to the centripetal force and simplify it to get the expression for kinetic energy. mv square by 2 is equal to mgr upon 2. Now we are going to equate the energies at A and B. So at A it is mgh, at B it is mg into 2r plus mv square upon 2. Interestingly, in this expression, when we substitute for mv square by 2, we get mg in all terms, and that is going to get cancelled. This means the mass of the marble is of no consequence. If a light marble loops the loop, a heavy marble would also loop the same loop. This is true in roller coaster rides also, those loop a loop, that whether the ride is occupied or whether it is empty, it always loops the loop. So finally, after cancelling this mg and simplifying, we get h, the minimum height required, is phi r upon 2. So we should release this marble at least from 2.5 times the radius height so that it loops the loop.